Our learning standard is SY7. I can graph a system of linear inequalities or write a system of linear inequalities given a graph. If you are watching this video, I hope you've printed out the worksheet that goes along with it, the SY7 Extra Practice, which has a couple of examples that I will work through with you, and some guided practice, as well as some individual work for the back. Let's start with that upper left slope-intercept example. The system is not written on your worksheet, so you're going to go ahead and need to write in each inequality one at a time, and then we'll consider the system. So the first inequality that you're writing is y is greater than 1/2 x plus 3. Just like in Unit 4, we find the slope, just a second, as the coefficient in front of the x, 1/2, and the y-intercept as the y value when x equals 0. So we plug in 0 for x, we're left with 3 for y. If we were in Unit 4, we would plot a point at 0, 3, and then use a rise of 1 and a run of 2. Up 1 over 2. Up 1 over 2. And then working backwards. So rise of 1, run of 2. The difference between Unit 4 and Unit 6 is now we are not considering the line as the solution. That would be the solution to the equation. The solution to the inequality is going to be a region of the graph where the line is the boundary line. So it marks the edge of the solution set. Before I graph that boundary line, I need to decide, is my boundary line dashed or is it solid? If we had greater than or equal to or less than or equal to, that would be a solid line because that would indicate, because of this equality, that points on the line were parts of the solution set. Since we don't have that equality, points on the line are not a part of the solution set, and we are looking for a dashed line. So here is my dashed line. That's my boundary line. And points on that line, again, are not a part of the solution set. In determining the shading, which of course there will be shading, the graph of an inequality is a region and always involves shading. So because we have this symbol, this is our greater than symbol, we will be shading the region directly above the line. Those little arrows are helpful to me, especially when the line is steep, to figure out what exactly is above the line. Okay, so there is my graph of y is greater than 1/2 x plus 3. And again, it indicates that every single point in this region is a solution to the inequality. Every single point satisfies this inequality. So let's say, hey, -4, 6. Does that satisfy the inequality? Is 6 greater than 1/2 times -4 plus 3? Is 6 greater than -2 plus 3? Is 6 greater than -1? Yes, it is. So again, each and every point above this line is going to be a part of the solution set. And you should be graphing that right along with me. The second inequality that you're going to graph, or we're going to graph, is y is less than or equal to 4x minus 5. So on your paper, you're writing the slope, the coefficient in front of the x, and then the y-intercept, which is the y value when x is 0. Plotting 0, -5, and going up 1, 2, 3, 4 over 1, rise of 4, 1, 2, 3, 4, run of 1, up to 1, 2, 3, 4 over 1. Because we do have this equality component of the symbol, our boundary line is now going to be solid. So you should be using your straight edge to draw that solid line. And I should have mentioned, when you're drawing your dashed line, I want you to right away draw a dashed line rather than trying to draw a solid line and erase. All right, so now we're looking at a less than, and actually a less than or equal to in this case, symbol. So we will be shading below the line. What color here? Let's go with yellow. So this is my graph of the inequality y is less than or equal to 4x minus 5. So considered separately, my graph of y is greater than 1/2 x plus 3 is this region, the region above that line. My graph of y is less than or equal to 4x minus 5 is the yellow below the line. And then this area right here, which I'm going to make orange, even though that's not really orange, green and yellow, is my graph of the system. Y is greater than 1/2 x plus 3 and y is less than or equal to 4x minus 5. And only points in this region would satisfy both inequalities. Points in the green region would satisfy y is greater than 1/2 x plus 3, and points in the yellow region would satisfy y is less than or equal to 4x minus 5, but only points in the orange region satisfy both. Okay, so that should be graphed on your paper, and now you're going to do one alone. So on your paper, there's a part that's marked slope-intercept guided practice, and I'm going to give you one inequality at a time. So y is less than or equal to 3x minus 2. I want you to graph this inequality on your paper, indicating the slope, y-intercept, dashed or solid above or below. And I would like you to press pause while you do that and then come back and check your work. So I hope you pressed pause, and let's see if our graphs match. Do they? Do you have a y-intercept of -2? A slope of 3? Are you graphing a solid line since we have the equality? And are you graphing below since we have that less than sign? If not, go ahead and pause and fix it. Otherwise, you can start with the second inequality, y is greater than -2x plus 1. Pause and then come back. So hopefully you paused and you graphed y is greater than -2x plus 1, and let's see if we match. Do we? Slope of -2, y-intercept of 0, 1. We have a dashed line since there's no equality, and we are shading above the line since we have a greater than symbol. Again, orange, not part of the solution to the system. Green, not part of the solution to the system. The solution to the system is every single point in this green-orange region, including the points on this line segment. Well, actually, I guess array, but the points on this part of the line, but not the points on this dashed line. Moving along to your standard form example. Let's consider this inequality. 3x minus 2y is less than or equal to -12. So write that on your paper. When we are finding the x-intercept, we let y equal 0. And the equation that we solve is 3x equals -12. So this whole term disappears since y equals 0. We solve for x and we get x equals -4, meaning my x-intercept is x equal to -4, y equal to 0. My y-intercept, the equation I solve, is -2y equals -12 because I let x equal 0, causing that term to disappear. You can see why we want to set this as an equation. I mean, we're looking at a boundary line, but if we had an inequality here, it would be confusing. We would think we need to flip, and that is not the case. So when we're looking at intercepts, graphing by intercepts, we want to use the equation for the boundary line. All right, y-intercept of 0, 6. And then since we have an equality, we're looking at a solid line. Graphing the boundary line. 3x minus 2y is less than or equal to -12. I just connect that x-intercept of -4, 0 and the y-intercept of 0, 6. When we're trying to decide, are we shading which side or which region of the graph we're shading, we can't trust the inequality for standard form equations or inequalities. So I'm going to go ahead and plug in the origin here. If I plug in 0 for x, I get 3 times 0 is 0. If I plug in 0 for y, I get 2 times 0 is 0. And 0 minus 0 is 0. The whole left-hand side becomes 0. And that's actually why we choose the origin. So we're checking, is 0 less than or equal to -12? Is 0 less than or equal to -12? No, it is not. That means that the origin is not a part of the solution set to this inequality, and I want to shade the side of the inequality that does not contain the origin. So that is going to be this side. This is the side of the inequality 3x minus 2y is less than or equal to negative 12. That does not include the origin, since 0 does not satisfy the inequality. My second standard form inequality is 2x plus 5y is greater than 10. My x-intercept I find by setting y equal to 0 and solving for x. So I have 2x equals 10, inverse operations dividing by 2, which gives me an x-intercept of x equal to 5, y equal to 0. My y-intercept is found by setting the x term equal to 0. Giving me a y value of 2 when x equals 0. Okay, so 0, 2. Before I graph that boundary line, I need to decide dashed or solid. We are dashed here since there is no equality in the symbol. So I need a dashed boundary line. I can find it. There we go. Okay, connecting-ish. Since I had such a hard time, I'm not going to try to change it, but I'm connecting-ish my x and y intercept. Oh, goodness. And then I need to decide which region of the graph I'm shading. So I plug in 0 for x, 0 for y, and is 0 greater than 10? No, 0 is not greater than 10. So I'm going to shade the region or the side of the inequality or of the boundary line that does not include the origin. So since 0 is not greater than 10, I'm going to shade this side of the inequality. And a lot of you have noticed when the coefficient in front of y is negative, that's when I can't trust the inequality, because that's when I transform into slope-intercept form, a flip happens. But I wouldn't recommend memorizing that rule. I just recommend plugging in x equals 0, y equals 0, and checking to see, hey, should I shade the origin? Okay, so here my solution to the system is not this orange region. It's not the green region. It's the overlapping region right here. Let's make it a different color. The points, the points in that region satisfy both of the inequalities. Okay, so now you're going to try a standard form example by yourself. So 2x plus 2y is less than or equal to 8. I'd like you to write that on your paper. Press pause, and then come back after you've graphed it. So hopefully you press pause, and let's check. Does your graph match mine? We have an x-intercept of 4, 0, a y-intercept of 0, 4. We have a solid line since there's an equality, and 0 is less than or equal to 8, meaning I shade below the line right here, the region containing the origin. If you agree, let's continue. If yours does not match, go ahead and pause it and fix it before moving on to our second guided practice example, 6x minus 3y is greater than 12. Go ahead and push pause, graph that inequality, and then come back. Okay, hopefully you paused, and now let's check. Does your inequality match mine? I have a x-intercept of 2, a y-intercept of negative 4. I have a dashed line since there's no equality here, and is 0 greater than 12? Nope, so I'm graphing the region onto the graph that does not include the origin. Okay, so green region satisfies 2x plus 2y is less than or equal to 8. Orange region only satisfies 6x minus 3y is greater than 12. Let's see what color we come up with here. My purplish region is my solution to the inequality. all the points in this purple region will allow 2x plus 2y to be less than or equal to 8, and 6x minus 3y to be greater than 12. Okay, so there is your guided practice and your example work. What I'd like you to do is turn to the back. The back is a little bit, it guides you through it as well so that you can identify slope, y-intercept, dashed, or solid. On the bottom, those same tips help you identify the inequalities that you're writing yourself. And I'd like you to go ahead and do this worksheet and then bring it in before after school advisory, before class, and ask me any questions that you have. Okay, SY7, good luck.